All right, so I think we're recording. Let's take a look at our homework from Skill 6B, where we're doing operations on radicals, and this homework focused on multiplying radicals. So if we take a look here at number one, we have two factors. The first factor is the square root of 3. The second factor is the binomial. And when you have multiplication, multiplication distributes over addition. So we take the square root of 3 and we multiply it times the first term. And then it jumps over the addition, and the square root of 3 multiplies that second term, the square root of 3. Now, since these have the same index, the index, it's implied that it's a 2. These are square roots. We've got the square root of 3 times the square root of 10. And 10 just breaks down to 2 and 5. So this is 2 times 3 times 5. We don't have any pairs, so we're going to write this underneath one radical. But here, when we have the square root of 3 times the square root of 3, that underneath one radical, that's the square root of 9. You have a pair of 3's, so that simplifies that the square root of 9 is 3. So there's our final answer. In number 2, it's similar. We again have two factors. Factors are separated by multiplication or division. So this first factor is square root 2. The second factor has two terms, 2 and the square root of 2. When you're multiplying a monomial times a binomial, the multiplication distributes over addition or subtraction. So each term inside the parentheses gets multiplied by the square root of 2. And I'll write it this way this time, square root of 2 times 2, but most of the time we put values like this in front of the square root. And here's square root of 2 times the square root of 2, because the multiplication distributed over the addition. So like I say, we write the 2 in front. Multiplication, it doesn't matter the order, but I think the reason that most of the teachers did it when I was a student, I think, is so that you copied it down right in your notes, and that you didn't write it sloppy, and that if this bar gets too close to that number, then you're like, wait a minute, is the 2 underneath there, or is it not underneath there? And you begin to question that. Anyway, that's what I've always done. And here, since it's the same index, since these are both square roots, we can place this underneath the same radical. And we know that the square root of 4 is 2. And so there's our final answer. So the idea is the same on this problem. However, we have negative signs that we're going to have to deal with, and we have numbers in front of the radical. So it just requires being careful. And again, multiplication distributes over addition or subtraction. So this first factor, and here's the second factor that's a binomial, we take this factor and we distribute it to each term. So this negative 5 times the square root of 6, we multiply it times this first term, the number 3. And then with this negative and this negative, we change this to addition, and we have 5 times the square root of 6, and then that's being multiplied times this term, which is 3 times the square root of 6. You can multiply things in any order. So what they expect us to do is to take the negative 5 times the 3 and write that as negative 15. And it is suggested that you put that in front of the radical, that you have radical 6 here. In the second term here, we have 5 times 3, which is 15. And square root of 6 times the square root of 6 is the square root of 36. So you know that anytime the radicands are the same, the radical just goes away. You have 15 times 6, because 36 is 6 squared. And 15 times 6, I think, is 90. And that's our final answer for number 3. For number 4, we have 2 factors. And the distributive property says that multiplication distributes over addition or subtraction. So this factor gets multiplied times the first term, and this factor also gets multiplied by the second term. So when we do that, well, let's write it out. We have negative 5 times the square root of 3 times a negative 2. I'm going to put that in parentheses because otherwise I'm afraid people will think, let's do this. Let's put it in parentheses, implies the multiplication. And we have this guy, and it's multiplying this. All right. So with the negative times the negative, I'll adjust that sign right now. And I have 5 radical 3 and 2 radical 3. So with multiplication, you can shuffle the order here, and we can take the negative 5 times the negative 2, and that's a positive 10. Now, 10 breaks down to 2 times 5, and then you've got this times 3. So the square root of 30 is not going to reduce. There is no pair of factors when you break down 30. Because you can see that right here, that you've got 2 and 5, and with this 3, you look at those 3 factors, and there's no repeats. The 5 times 2, the numbers that are the coefficients, the numbers in front of the radical, we multiply them together. And when we multiply the radical 3 times the radical 3, we know that that's square root of 9, which is 3. So when you're, you can save your writing in a step now. Before I was writing that down just to illustrate it so you could see it. And now you probably recognize that, hey, the square root of 3 times the square root of 3 is just 3, because I have a pair, and that's what square roots are doing, is looking for pairs. So this first term is 10 times the square root of 30, and 10 times 3 is 30. Those are unlike terms, and we cannot combine them, and this is our final answer. So this problem is similar to the others. We've got 2 factors. this first factor does have a coefficient in front of the radical, and so does in the second factor that is a binomial, that first term does as well. Well, multiplication distributes over the subtraction. This factor, we multiply it times the first term of that binomial, and then it distributes over the subtraction, and we multiply the second term of that binomial. So if we have 3 radical 15 times negative 2 radical 5 minus 3 radical 15 times a radical 3. So if we have a positive 3 times a negative 2, that's negative 6. And now when we take 15 times 5, we know that we're going to be able to break down this 15 to 3 times 5. So all of this is underneath one radical, and so 15 times 5 breaks down to 3 times 5 times 5. And hey, you've got a pair of 5s right there. So that's how we're going to simplify that radical. And here we've got minus 3, and the same idea that 15 is 5 times 3, and you have this 3. So underneath this radical, you have 5 times 3 times another 3. So this pair, we break this apart, and we say, well, what is the square root of 3? Well, I can't simplify that. What's the square root of 25? 5, because 25 has a pair of 5s. I can't do anything with this square root of 5. It's not a pair, it's just a single value. But I do have a pair of 3s. This is saying take the square root of 9. And the square root of 9 is 3. So I have multiplication here, so this gives me negative 30 times the square root of 3. And this is minus 9 times the square root of 5. And the 3 and 5, these are unlike terms, so I can't combine them. And this is my final answer. Let's take a look at number 6. So the idea is beginning to get repetitive, kind of a repeat, which is good. When you begin to recognize that it's repetitive, that the only thing that's changing is just the numbers, then you know you're understanding how to get the right answer. You just have to do the arithmetic. In this first factor, don't lose that coefficient. We've got this factor gets multiplied by the first term in the binomial. The multiplication distributes over the addition, and we multiply it times the second term in the binomial. So we've got this 3 radical 15, and we multiply this opposite of the square root of 2. And then we have adding 3 radical 15 times 5 radical 3. So the 15 breaks down to 3 times 5. And 2 already is a prime number. So when we look here at these factors, we can place this underneath one radical, but we don't have any pairs, so we're not going to be able to simplify that. We've got this negative sign, and I'll move that with the 3. Like I said, you can think of this as a negative 1 if you want, and negative 1 times a positive 3 is negative 3. And underneath this radical, 3 times 5 times 2 is 30. And we cannot simplify the square root of 30. Now over here, we are going to be able to simplify. We've got 5 times 3, and then with this square root of 3, hey, you have a pair of 3s. So let's multiply the numbers that are in front of the radical first. 3 times 5, that's 15. Now, when I look to writing the square root and putting this underneath one radical, then we have, well, let's go ahead and do it so I don't skip too many steps. We've got 5 times 3 times 3. That's what 15 times 3 is. I went ahead and broke 15 down now so that I can easily see that I have a pair. So I've got negative 3 radical 30. And I've got 15 here. And since I have a pair of 3's, I have a 3 to the first power that comes out. And the 5 didn't have another factor of 5. It's all by itself. So that's the square root of 5. So our final answer, negative 3 times radical 30 plus 45 times radical 5. And those are unlike terms, and I can't combine them. There's my final answer. Let's take a look at number 7. So this problem is different than the others because my first factor was just a single term, a monomial in the previous problems. Now I have two factors, and the first factor is a binomial, and the second factor is a binomial. And we know, though, with multiplication, that the underlying rule that we want to apply is the distributive property. And I suggest when you have a binomial times a binomial, that you multiply this in the form of a table. So go ahead and write down the first two terms and put those on the side of this 2 by 2 table. And across the top, go to your other binomial and write those terms. And now this is just kind of an organized way to apply the distributive property. So when we multiply 2 radical 5 times radical 5, we know that that's the square root of 25. We know that you have a pair of 5's, so a 5 comes out underneath from that radical. Now here we have 2 times the square root of 5. Well, 2 times 2 is 4. And we can't simplify the square root of 5. It's just a single factor. It's not a pair of numbers. And here in this box, I have 5 times the square root of 5. And I can't really do anything with it other than write them next to each other. That implies multiplication. And 5 times 2 is 10. Now I do notice that when I look along this diagonal, that these are like terms. So I'm ready to use my table. That helped me apply the distributive property in an organized way. And this first cell right here, this first entry, 2 times 5, that's 10. And this diagonal, 5 radical 5's plus 4 more radical 5's is 9 radical 5's. And look at this entry in this cell right here. It's another 10. So those are like terms, and 10 plus 10 is 20. But I cannot combine 20 and the 9 radical 5. So this is my final answer. All right, so let's move on to the next one. So again, I see a binomial times a binomial. And I hesitate to emphasize to students to use the phrase FOIL because FOIL will only work with the binomial times a binomial. Whereas when you're using a table, you can use that idea of a table even if one of these is has more terms, a trinomial or four terms or whatever. So I believe it's probably a wiser idea for you to use a table as an organized way to apply the distributive property. FOIL, I mean, basically, you can look at these entries in this table as spelling out the word FOIL, but I think the table is going to be better because it's more useful in other applications in more difficult problems. So we have these two terms. If we write 1 and the second term, -3 times the square root of 5, and we've got 2 and -5 times the square root of 5. So to get the entries inside the table, you just multiply the outside values where they intersect. We've got 1 times 2 is 2. 1 times, it's easy to multiply by 1, right? I'm pretty fast at it. So 2 times -3 is -6. And a negative times a negative is positive, and 3 times 5 is 15. And the square root of 5 times the square root of 5 is the square root of 25. We know that we have a pair of 5s here, so that just simplifies to 5. All right, so what do we have? Well, along this diagonal, we have like terms. And we actually have like terms along the other diagonal as well. They're constants, but I'm going to have to multiply the 15 times 5, so I'm just going to do it down here below the table. -6 radical 5 and another -5 radical 5 gives us -11 radical 5. And 15 times 5, 75, added to that 2 is 77. And we can't, these are unlike terms. We can't combine these. So this is our final answer. Let's look at the next one. We see the finish line in sight. We've only got 2 problems to go. So it's similar to the last problems that we've been doing. We have a binomial times a binomial. Now, we do have to be careful when we're applying the distributive property and we're multiplying these entries together because we've got so many negative signs. It's easy to accidentally make sign errors. I think being neat and organized in how you write your work is going to help out a lot too. So this binomial, I write these individual terms, say on the left, and across the top, if I write these terms. Now I want to multiply these outside entries to fill in my table. So I can think of this having a 1 right here. -3 times the positive 1 gets me -3. And the square root of 5 times the square root of 5 is the square root of 25. And since we're looking for pairs with square roots, we know that we have a pair of 5s here. So that product is just 5. Now the -3 times the -3 is 9. Now 5 and 3 are both prime numbers. They don't break down any further. And we don't have a pair of 5s or a pair of 3s. So I'm going to go ahead and put this product underneath a single radical. 5 times 3 is 15. And the same argument is held for this one down here. The positive 1 times -2. And when I multiply square root of 3 times the square root of 5, it's the square root of 15. Now here in this entry, I have a negative number times a negative number, so I know it's going to be positive. I have 2 times 3, which I know to be 6. And I have the square root of 3 times the square root of 3. That's the square root of 9. And we know we're looking, since it's square roots, that we're looking for pairs. Well, we had a pair to begin with, the 3 and 3. So we have 6 times 3. Along both diagonals, they're like terms. But I'm going to go ahead and do the multiplication down here and then add those terms. So I don't want to try and do too much in the table without writing down a little bit of steps. Negative 3 times 5 is a negative 15. And 9 radical 15s take away 2 radical 15s, and I have 7 radical 15. And 6 times 3 is 18. So like I say, these first term and last term there are like terms. We can combine them, and negative 15 plus 18 is just a 3. So I can't do anything more with this. I can't simplify it. This is in lowest terms. All right, let's move on to the next one, which I think is the last one. So see, even I get excited about the last one. Although I just have to go to the next video. All right. We have a binomial times a binomial. We know that when we have multiplication and we have these parentheses and we have more than one term, the distributive property is important. And a nice organized way to apply this distributive property is in the form of a table. So we have these two terms along one side of the table. I put each of the terms, and across the top, I come to the other binomial and put down each of its terms. So to figure out the number inside the table here, we multiply the corresponding entries, the intersecting. You can see that how these two intersect. We want to give the product of those values. So 5 is a prime number, but square root, if they gave me square root of 4, I guess you know what? I don't know why I wrote that. It's super obvious what the square root of 4 is, right? This is 5 times 2, so isn't this just the number 10? I may as well simplify it now, especially since it was so easy to do it. I was just blindly copying down what they gave me, and I should have looked at it and said, oh yeah, hey, over here, this is 10 plus the square root of 3. Now, 10 times the square root of 5 is 10 radical 5. And this times this is 3 times radical 5. And 10 times that is 10 radical 3. And here 3 times that is 3 radical 3. So we have some like terms, but it's unusual most of the time that you see like terms being horizontal or vertical. You know, they're usually diagonal if we have it in some type of standard form. But we had we had that radical in there that we simplified before we applied the tables. That could be part of it. So I've got 10 radical 5s plus 3 more radical 5s. See how these are like terms? So I've got 13 radical 5s. Now down here, do you see how I have radical 3s? Again, I have 13, but this time it's a radical 3. So there's my final answer. I can't add these two because they're unlike terms. Well, I hope that helps. Let me know if I've made any silly mistake. Let me know if you disagree with these answers, and we can talk about it. I'm at school, before school, and after school if you want to do it then, or I'm sure that you can probably find some class time to ask me a few questions as well. So I'll talk to you later. Bye.